Okay, welcome back. Now we're going to actually do example number 2. The example number 2, there's a farmer who wished to actually use 540 meters of fencing to create 6 equal sized rectangular plots adjacent to one another as shown here. Now if the length and the side of each plot is x and y, okay, this is x, this is y, and the farmer wished to fence out 6 of this, okay, using only 540 meters. Now this is the condition, okay, show that y must be this value. Now to do that, right, we need to know first and foremost how many x and y actually add up to become 540. Now if you know this is 1x, this will be 2x, this should be 3x, 4, 5, 6, 7, 8, 9. So we have 9x. Okay? And y, right? This is 1y, 2y, 3, 4y, 5y, 6, 7, 8. So we're going to have 8y to give us 540. Now this is the condition. Of course, from here, right, we can make y the subject. 540 minus 9x, and of course we can show this 540 minus 9x divided by 8. Now we have shown part 1. This is your part 1. Now for part 2, right, if the total area of these 6 small plots to be a meter squared, can you show that a has this formula, or the function a, right? A, right, is a function of x only. Okay, so we know that from part 2, right? Okay, maybe I move forward. We know this. We already got this already shown, okay, earlier. Now we know that the area must be 3x times 2y, because if you to look, right, the area will be 3x times 2y, because the 6 plots here are adjacent to one another as shown here. Okay, so we are going to get 6xy. Now in other words, the area A is in terms of x and y, and they want you to show that it is only in terms of x. So we are going to actually substitute y using this formula here. Okay, so when we do that, we got this. Now 6 and 8 we can actually take out and simplify it to get 3/4. Okay, 540 and 9 has a common factor of 9, so we're going to get 60 minus x, and that's it. We're going to get here. Okay, I multiply 9 and 3, and we are going to multiply x into the bracket, inside the bracket, and we got this. Now, so we have done part 2. Now look at part 3 again. Okay, part 3 wants you to calculate the value of x for which a has a stationary value. Okay, and then after that you got to show that this value of x makes a minimum, and you got to find this maximum area. So in other words, there are 3 verbs here that we need to do. One is to calculate the value of x when a is stationary, and then you got to show that this value of x makes a maximum, and we got to find this maximum a. Okay, so there are 3 parts. We do slowly. Now of course we know this. When a is stationary, dA dx must be equal to 0. So we need to find dA dx and then set it to 0. So dA dx, right? If you take note, this is a multiple, a constant multiple. So we can bring out and we differentiate here. Okay, so when we differentiate this, we are going to get 60. Okay, can I rub here a bit? Okay, okay, we are going to get 60, right, minus 2x. Of course, when you set this to 0, okay, set this to 0, you are going to get x equals to 30. Am I right? Okay. Now, so how are we going to actually really find first one? How are you going to show that at this x equals to 30, okay, A is maximum? Again, we got a choice whether you want to do by first derivative or second derivative test. Again, I have to actually look at my dA dx, and I realize that dA dx is actually a very simple function to differentiate. So again, I choose the second derivative test. So to do the second derivative test, right, d2a dx squared, okay, I'm going to actually get, this is a constant, basically 27 over 4, okay, d dx 60 minus 2x. Now I'm going to get 27 over 4 times negative 2. Now, this one, of course, you can just, it's very simple, right? It's actually negative 54, okay? Divide by 2, right? Negative 54 divided by 4. Now, of course, we can simplify, but I choose not to because I can actually find the sign that this must be less than 0. So now, when d2y is d2a and dx squared is negative, we have already shown that A is maximized. Now, before I carry on further to find this maximum value, can I just explain one very important concept? Now, when you find d2a dx squared, remember the earlier example is in terms of x. Now, this one is not in terms of x, it's independence of x. Okay? In other words, whatever value, stationary value of x that we find, it has to be maximized. So the d2a dx squared, right, depends on whether the value, okay? Sometimes it gives you a negative value or positive value, and sometimes it gives you in terms like a formula, and then you got to actually substitute x equals to 30, for instance, okay? Now, so what is the maximum value of A? Of course, we can find that from the formula here, okay? We just substitute and you're going to get the formula.